Okay, so we have this wonderful warm-up. F of x equals x cubed, g of x equals x squared. What is the derivative of f times g? So a lot of groups said, hey, the derivative of f is 3x squared, and the derivative of g is 2x. So the derivative of f times the derivative of g is 6x cubed. All of this is actually true. Like, this is a true statement. Everything that I've written here is true. However, the question is the derivative of f times the derivative of g the same as the derivative of the quantity f times g? So I'm going to ask middle group. Not much. How you guys doing?
Never been better.
Never been better. That's awesome. All right. So let's see if that stays when I ask you to tell me how you got your answer.
So we took f of x and multiplied by g of x.
All right. So they said, hey, f times g is equal to x to the fifth. So then they said, oh, well then the derivative would be 5x to the fourth. So we have two different answers. Which one do you think is the correct answer? The 5x to the fourth? Yeah. We know this has to be correct because we're asked for the derivative of f times g, and this is the derivative of f times g, whereas this is the derivative of f times the derivative of g. So now you know that the derivative of the product is not the product of the derivatives. So yesterday we learned, so those of you who weren't here, hopefully you all watched the screencast. If you didn't, you better watch it soon. We have a lot. If you are out for something like orchestra, you are required that day, that evening, to watch that screencast and get caught up, because we're going to use what we learned yesterday in today's lesson, and you'll be behind, like you'll be more behind if you didn't catch up. So it is your responsibility if you're out for a field trip to stay caught up on all your other classes, and that includes watching the screencast and doing the homework. Okay, that being said, so yesterday we learned the power rule, constant rule, the constant multiple rule, and the sum and difference rule. Today, notice what was noticeably absent yesterday was a product rule and a quotient rule. That's what we're learning today. All right. So today we're doing section 3.2. I can apply the product and quotient rules. Okay. All right, product rule was actually discovered by Leibniz. He figured it out by drawing a picture. So he said, hey, if this is u and this is v, then u times v can be represented as the area of this rectangle. Well, if the change in u is this distance and the change in v is this distance, then this area right here, well, that would be v times delta u. This area right here would be u times delta v. So the change in our rectangle, in our area, would be v delta u plus u delta v. This guy doesn't account for in the change in the area. It's just those two rectangles. So that's what Leibniz figured out, and by doing that, he created what we call the product rule. Now, he wrote the product rule in kind of a complicated way. I am going to have you learn this way, which is the exact same thing, just without all the fluff. So when I do oh, yes, maybe.
I was going to ask the small.
Because the small square isn't a part of the change. It's just that extra stuff. He wrote what it was, but it's not technically a part of the change of the rectangle. It's just going out and up, not out. I don't know, does that make sense? Okay. All right, so, and there is a way to show it mathematically, but I don't want to get into it right now. Okay, yeah, I personally, I'm more of an analytical person than a picture person, although I do like pictures sometimes. So for product rule, the derivative of f times g is f prime g plus fg prime. So it's the derivative of the first function times the second plus the first times the derivative of the second. F prime g plus fg prime. As a matter of fact, I like saying that. F prime g plus fg prime. But it's got a rhythm. F prime g plus fg prime. Everyone say it with me. F prime g plus fg prime. Say it again. F prime g plus fg prime. One more time. F prime g plus fg prime. Brian, let me hear you say it.
F prime g plus f g.
Good job, Anthony.
F prime g plus f.
Well done, Jennifer.
F prime G plus F G.
You rock. Okay, so Kirtan, you want to say it real quick?
F prime G plus F G.
You got it. We got this, right? Charles, say it. You got it. We rock. All right, f prime g plus fg prime. Learn that, know it. Because remember, in AP Calculus, there's no such thing as a formula sheet, right? And there's no such thing as a note sheet. It's all got to be in here. So make sure that whatever you need to do to memorize, right? So for me, a rhythm kind of helps. F prime g plus fg prime. So, and personally, I don't actually think that when I'm doing derivatives. My brain just thinks derivative of the first function times the second plus the first times derivative of the second. That's what my brain thinks. It doesn't think f prime g plus fg prime, but it's okay. All right. You might be asking yourself, why do I need that when I could just multiply them together first and do the derivative, right? Is anyone thinking that? Yes? Good. See, look at all these honest people, right? Okay. So, hey, let's just see if it works real quick. So, this is our f prime, right? So we would have, if I wanted f times g prime, so it would be f prime times g, which is x squared, plus f, which is x cubed, times g prime, which is 2x. Let's see what we get. We get 3x to the fourth plus 2x to the fourth. Look at that! Yay! Okay, right? It's a lot of work. Why wouldn't we just multiply first and do the derivative, right? Dun, dun, dun. Because we're not going to give you that function. We're going to give you xe to the x. Good luck multiplying xe to the x together before you differentiate, right? They're pretty much as multiplied as they're going to get. So you're kind of stuck. So when you have to do a derivative of something like xe to the x, you have to use product rule. Now, a little note. Normally when you're using product rule, it's not like in your face, like this is f of x and this is g of x. What's the derivative of f times g? It's not that blatant. Normally it's just some function that has two things multiplied together. And you need to recognize product rule, right? So whenever you say, like if you were speaking the function and you say the word times, it's probably a product rule problem, right? The way that you know for sure is if you have something with a variable times something with a variable. And we'll get more into that in a few minutes. But right now, I'm going to rewrite down here so I don't have to reach up so high. All right. So I want you to take a minute. And so if this is our function, as far as the formula goes, with the f prime g and the fg prime, you want to think of it as kind of like f is like the first part, the first thing that's getting multiplied, and then g is like the second thing that's getting multiplied. So like that would be your f and that would be your g when you do your product rule. Take a moment, give it a shot, see what you think. He's already done. Do anything to simplify it? Did you understand that? Okay. So the derivative of x is 1 times e to the x plus. So now you put x times
Wait, what are we doing?
You got it. There are a lot of rules. You have only just begun. We've only just begun. You think there's a lot of rules? Tomorrow you're going to learn the derivatives of all 6 trig functions, right? Today we learn product quotient. Tomorrow you learn all 6 trig functions. Friday we do chain rule, right? So, and we haven't even talked about derivatives of like natural log or inverse trig functions, right? Yeah, there's going to be a lot. It's a lot of stuff to learn. So, yeah. Okay, here we go. So, think F. So, F. Oh, whoops, wait. I'm already doing it backwards. Okay, so F prime. So we do derivative of x. What's the derivative of x? 1 times g, which is our e to the x, plus f times g prime. Derivative of e to the x is e to the x. And you can leave it like that. That's fine, right? If I wanted you to clean this up, what could you do? Factor out an e to the x, and it would look like that. Everyone okay with that? All right, so that's part A. Part B says find the nth derivative. Now let me talk about notation for a moment. Those tick marks, yesterday I was showing you like prime, 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 right? And that meant like the 4th derivative. Technically, these tick marks aren't exactly tally or tick marks. What they really are is Roman numerals. So I know prime, 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 prime is really not exactly correct for Roman numerals, but say we had like the 17th derivative, you could write that, and that would mean the 17th derivative, right? You can use, if you are a Roman numerals fan, you can use Roman numerals for all of your derivatives, right? What most mathematicians do, because kind of once you get high, Roman numerals are kind of a pain. So what most mathematicians do is they write the derivative in parentheses. So when you see parentheses around your exponent, this doesn't mean the 17th power, it means the 17th derivative, all right? So parentheses means derivative, and we'll see that all the way through. All right, so they want you to find the nth derivative. Well, goodness, I don't know what the nth derivative of this is. I'd be guessing, right? So, what would be maybe something to find that might lead us along and see if there's a pattern? The second derivative, right? So everyone, I want you to find f double prime. You can use either this function or this function. I don't care. But I want you to take a moment and find f double prime now using product rule and see what you get. How'd you get that? What are you doing to find the derivative of x?
You bring the x.
Let me just point out, you just found the derivative of x. Oh, it's in part 1. Right? What did you use to find it? Product rule, right? This is a product rule. And it's actually the same.
Oh, so you just gotta use that.
Exactly. Anisha, how are you?
Good. What about you?
Thank you for asking. I'm doing all right.
I'm a little tired right now.
Are you?
Yeah.
Did you not get a lot of sleep?
Yeah.
Did you have a lot of work last night?
Yeah.
Oh, and you know what? I'm so sorry. It's recording while we're having this conversation.
Oh, no, that's okay.
Okay. All right. All right. Will you be able to get some rest tonight?
Probably not.
No. Yeah.
I have a gut test and I need to learn everything.
Such is the life of a student. Yeah. Yes. Maybe. Yes. Absolutely. You know what? I'll get it. Yeah. You're fine. Yeah. I like the door open because I like the kind of the air coming in and everything. But yeah, the noise is too much. Okay. So, Anisha, did you guys use this one or this one to find your second derivative?
We use the second one.
This
because
one?
It's like multiplied, so it's like easy to like split up.
Okay. So just know if you use the first one, the derivative of e to the x is e to the x. But what rule would you have to use for that guy? Product rule. Product rule. Again, right? As soon as you have a variable times something with a variable, you have to do product rule. How do you know? You just did it in part A. That exact derivative was what you found in part A using product rule, right? Whoa. Okay, so anyway, but we're going to use this one. So let's see if we get the same answer. Do you think we would get the same answer?
Yeah.
Okay, we'll hope so. So the derivative of e to the x is e to the x.
So much easier. Oh, okay. I understand what you were talking about earlier. Like you can replace the x e to the x with 1 e to the x.
Plus x e to the x. Yeah, because you already found it. But that's okay. I like doing this one too. It really, to me, it's potato, right? Okay, so the derivative of e to the x is e to the x times 1 plus x plus e to the x times, what's the derivative of 1 plus x? 1. So if we clean this up, we get e to the x plus x e to the x plus e to the x. Well, that's 2e to the x plus x e to the x. Or if I factor out an e to the x, it's e to the x times 2 plus x. So the first derivative is e to the x times 1 plus x. The second derivative is e to the x times 2 plus x. What do you think the nth derivative might be? And it is. So in general, now this doesn't prove the nth derivative. We are using what's called inductive reasoning when we make a decision based on a pattern. When you make a decision based on a pattern, that it's not always true. In this case, it is. So our nth derivative would be e to the x times n plus x, and it really only took 2 derivatives to see the pattern. If you think about it, every single time you differentiate, this x e to the x will become x e to the x plus another e to the x, and you'll just add it, and it'll just keep increasing this guy by another e to the x. So anyway, okay. So a little note, just know, because I saw a lot of people not using product rule for the second derivative, anytime you have a variable, so what I would call a variable expression times another variable expression, anything with a variable times anything with a variable means you are in product rule world. There is no way around it. Now, suppose I gave you fx equals 3x squared. Does this require product rule?
No.
No, this is constant multiple rule, right? Could we use product rule on it? Yes, you have to. Because if you can't, like you've just disproven product rule. Like product rule, any rule that math says is true has to always be true. It can't be true like for some and not for others. It has to be true with no exceptions. So product rule is no different from any other math rule. It's got to always be true, which means if you think of this as your f and this is your g, and we do f prime, what's the derivative of 3? 0 times x squared plus 3 times the derivative of x squared, which is 2x. So our derivative is 6x. Yay, right? So I don't think you're going to want to go through that exercise every time you have a constant multiplier, right? You can just do 6 times x to the first, right, and be done. But just know that it does work. It always works. Okay. So really, variable times variables when you use product rule. When there's a product, there's a quotient. All right. Quotient rule is so much fun. F prime g minus f g prime over g squared. There's no good rhythm to it. You just have to learn it. F prime g minus f g prime over g squared. F prime g minus f g prime over g squared. F prime g minus f g prime over g squared. Everyone say it with me. F prime g minus f g prime over g squared. Yeah, there's really no good rhythm to it. Okay, so kind of. Now, the thing to note, on top, what does it look like? It looks like product rule, except it's got a minus, right? So the top is really just product rule with a minus, and then the bottom, and then you got to divide by g squared. Now, there are other memory tricks for quotient rule. These are not mine. So this one belongs to like one of the greatest calculus teachers ever. Her name is Brenda Johnson. She moved to Wisconsin, but she's awesome. She used to teach here. And so this is hers. I give her credit whenever I use it. So she says low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's below. So low, so she kind of does g f prime instead of f prime g. So she goes low d high. When you have a d in front of something, it means the derivative of. So d is like an operator. In math, you'll see a lot of professors who never write the full like dy dx out. They just put a d in front of the function and assume you know it means derivative. So low d high minus high d low over the square of what's below. So that's her method. Years ago, I took a workshop at a private school in Atlanta. And I can't think of the woman. I know her first name was Becky, but I can't think of her last name. She was really good, though. I enjoyed that workshop a lot. It was a long time ago, but she was really good. So anyway, so she would call the top function high and the bottom function ho. So hers is kind of similar to Brenda's, but not exactly the same. So she would say ho-de high minus hi-de ho over ho-ho, right? So whatever works for you. When I am doing these problems, I'm not thinking of any of these. My brain literally does this process. When I have a derivative of a quotient, my brain says derivative of the top times the bottom minus the top times derivative of the bottom over the bottom squared. That is what goes through my brain 100% every single quotient rule problem. It has never changed in, 40 years, 30 years. No, I don't want to overage myself. 30 years of doing calculus. So anyway, so that's what I think. You think whatever you want as long as it's correct. Okay. So let's do, does everyone have it written down? Because you're going to need it. Okay. Okay, so first example, x squared plus x minus 2 over x cubed plus 6. Remember, in your formula, the f represents the numerator, The G represents the denominator. So you're starting with the derivative of the numerator times the denominator, and then minus the numerator times the derivative of the denominator all over the denominator squared. No shortcut to quotient. Yeah, this is a shortcut, isn't it?
Get rid of the x.
If I say simplify, then yeah. Well, I mean, if you want to simplify, you can do it. That's the correct answer. All right. Again, I forgot to pause. I'm sorry, people watching the screencast. I keep forgetting to pause. So here we go. You can FF though. All right. So y prime equals. So you start with the derivative of the top. The derivative of the top is 2x plus 1 times the bottom minus the whole top times the derivative of the bottom all over the whole bottom squared. So question, can you just leave it like that?
Yes.
So, all right. So, yes, I will tell you on your test, we do have 2 requirements for simplifying. And I will hold these requirements all through the units, not just on the test, but every time we hit these, you will have to get rid of them. You are never allowed to give me a negative exponent, and you're never allowed to give me a complex fraction. So no negative exponents, no complex fractions, anything else I'm okay with. So this right here, I would be fine with. It's okay. Yes? Oh, I don't care. Yeah, question was radicals versus rational exponents. I don't really care. But, what was I say? Oh, I do have a question to see if you know what simplified means. Just look at the bottom. If is simplified, say I said fully simplified, right? I know you can all multiply out the top and combine like terms. But let's look at the bottom. Would the bottom be simplified leaving it like this, or would the bottom be simplified if I like distributed it out?
There isn't a negative exponent or not.
Fully simplified is factored. So the bottom is fully simplified. You are right to say leave it. Okay, so yeah, you leave it. If you multiply things out that are already fully factored, you're actually unsimplifying, right? Fully factored is simplified. So if it's already fully factored, it's beautiful. Be done, okay? Oh, it's Bad Joke Wednesday, except it's not Bad Joke Wednesday because, moving on. So, I have two wonderful problems here. The first one requires what rule? Quotient rule. The second one requires what rule? Quotient and product. It's a combo. Now, here's a little piece of advice about the combo problem. Whenever you have a problem that has both quotient and product kind of all in one, you do quotient rule as like the umbrella. So you kind of think of it in terms of quotient rule, but inside of the quotient rule, you'll be doing a product rule. So quotient rule starts with the derivative of the top. So you have to find the derivative of the top, but in order to find the derivative of the top, you have to use product rule, right? So you kind of do quotient rule and then just do the product rule when it comes up. All right, so I'm going to give you maybe 5-ish minutes to see what you can do with both of these, and I'm going to circulate, and I am turning off the recorder. You're welcome. First one, we have to do a little quotient rule. What is the derivative of 3e to the x? 3e to the x, right? So you get 3e to the x times the bottom, 4x squared plus 2x plus 7, minus the top times the derivative of the bottom, which is 8x plus 2, all over the bottom squared. What about this minus 5? What's the derivative of negative 5? 0, right? That was just for fun. Okay, so that's it. You can stop there. So for for number 2, when we do our f prime, again, we're going to start by thinking quotient rule, but the first part of quotient rule is to do the derivative of the top. When you do the derivative of the top, as soon as you have something with x's times something with x's, you have to do product rule. So let's do a product rule inside of our quotient rule here. So f prime, so 4x times g, which is e to the x, plus f, 2x squared, g prime, which is still just e to the x. All right, that is just the derivative of the top times the bottom minus the top times the derivative of the bottom, which is just 8, all over the bottom squared. Woo-hoo! All right. Yeah, and if you have the e to the x factored out of every term, that's okay. Yeah, that's what I did. All right. All right. So we have one more problem, but we're not done after this problem. After this, I have 2 more things to show you, and then we'll be done. So this is a very common AP question to see if you know product rule or quotient rule or chain rule or all the different types of rules. So to see if you know, you haven't learned chain, it's okay. To see if you know your rules, the College Board loves to give you tables and then make you figure out the derivative from the table. Now, how do you do this? Well, let's read. It says find h prime of 2 if h of x equals g of x over f of x plus g of x. Now, the College Board is evil, right? Let's just say that right now. So how are they evil in this problem? Because they put g on top and f on the bottom.
Oh my gosh.
Right? So that means when you're doing your quotient rule, all your f's and g's get switched around, right? Okay. So here's the thing. In order to find h prime of 2, first you're going to have to find h prime of x, right? You always have to find h prime of x first, and then you can plug in the 2. So I want you guys in your groups to take a minute, and here's your h, right? H is up here. Find the derivative of this. It's really just writing down the rule, all right? So see if you can write down the rule for h prime. So take a minute, write down h prime. Hey, Ivana, how are you? How's life? Good, apart from the coffee spill. Yeah. Yes, okay. So can you tell me what you found for h prime? I'm ready.
G prime x
Woo, woo.
times
Hang on, sorry, my screen just flew around. Okay, g prime of x times,
f of x
uh-huh,
minus g of x times f prime x all over f of x squared plus g prime x.
don't forget that little g prime off to the side. Derivative of g is g prime. Good, is that what you all got? Yeah, sorry.
The plus g of x, isn't that just 0?
Is g of x a constant? Or is g of x a function? It's a function. Yep. Good question. See, the more we question, the more we learn. All right, so now you've got this beautiful formula, and all you have to do is plug in a 2. So wherever you see an x, you're going to plug in a 2. So h prime of 2, I'm going to write out the whole formula again. It would be g prime of 2 times f of 2 minus g of 2 times f prime of 2 over f of 2 squared plus g prime of 2. All right, I give you about 30 seconds. See if you can find those numbers in the table. I'll give you a hint. They're all on the bottom row.
Oh.
And now you just
I'm going to scooch this up so we're right. F prime, G prime. That's all enough. Just so I can see a little bit. There we go. Troon, are you ready? Because you're going to walk me through this whole thing. Are you ready? Yeah. All right. Troon, what's g prime of 2?
2.
What's f of 2?
-2.
Okay. Minus, what's g of 2?
-4.
What's f prime of 2?
4.
All over, what's f of 2?
-2.
-2 squared. Plus, what's g prime of 2?
2.
2. So, Troon, we end up with -4 plus 4, which equals what? We end up with 0 over 4 plus 2. What does this whole thing equal? 2. All right. Yes, me.
Would you be required to like simplify more, or can you leave it?
Oh, question was, could you leave it? If this was a free response question on an AP exam, this right there would be absolutely fine. Right? Numerically equivalent to correct is correct. Okay. Yes, good question. All right. Now, we're done, except we're not done. So, first question, because I don't remember if I showed this class or not. Did I show you a 3-way product rule? I didn't. Okay. So, we know the derivative of f times g is f prime g plus fg prime, right? What if, for the heck of it, I gave you f times g times h?
Is it x times g?
Oh, wait, okay, wait. Brian, I want you to see if you can figure it out. You tell me.
Is it f prime times g h plus f g prime h plus f g h prime?
You got it. You nailed it. Well done. All right. So it's always just each derivative times the other functions, right? If you had 4 functions, God forbid, but if you did, right, say you had FGHI, it'd be F prime GHI plus FG prime HI plus FGH prime I plus FGHI prime, right? It's each derivative times all the other functions. Good, well done. All right, the last note I need to give you is for the quiz that I'm about to hand out. Okay, so we're going to talk algebra for a minute.
Algebra 1.
I think this is more algebra 2. Okay, all right. So the two things that you have to simplify: no negative exponents, no complex fractions. Suppose you do a beautiful little quotient rule and you end up with the following, right? So suppose you have some function and you have just said the answer to f prime of x is 3x squared plus 4x to the negative third over x plus 5. One of the most common algebra mistakes is not knowing where to put that x to the negative third. So I'm going to show you what not to do. So guys, just keep watching. So the most common mistake I see is saying that this equals this. Why is this wrong? Yes, Faith.
Because 3x squared over x to the third isn't like the same as 3x squared.
Yes, exactly. Because this x to the negative third isn't being multiplied by the quantity 3x squared plus 4. It's only being multiplied by the 4. So you can't apply it to the whole denominator of the whole thing, because then you've just said that it's being multiplied by the quantity, right? So this, bad algebra. So what do we do instead? Where does the x cubed go? It goes under the 4, because that's where it's being multiplied. But now we got a complex fraction, right? So what do we do to get rid of the complex fraction? Multiply the top and bottom by the LCD. So what would be our final answer? It would be 3x to the 5th plus 4 over x to the 3rd times x plus 5. Yes,
Would you be able to like just take the original fraction and then split it so it's like 3x squared over x plus 5? I mean, that's plus 4x over x plus 5. And then just take the x
third under the 4. Yeah, that works. That works. I personally, here's the problem. I will tell you the problem with that. So, it would be technically correct, but if you don't know how to do this, you're going to die in the next chapter. Because the next chapter, what we're going to make you tell us is where is this derivative equal to 0, and where is this derivative undefined, and if you have two separate fractions, you're going to have to sit there and combine them every time. So it's a lot easier if you just keep it as one big fraction so you can find the zeros and the undefined values really. Okay, but that's it, technically be correct though. Good, any other questions? Oh, yes?
Can I just like factor out the x to the negative third and then do it like?
Yes, you could. So there's other strategies. One of the other strategies is pull an x to the negative third out of each term. If you do that, when you're factoring out, you're technically dividing, right? So x squared divided by x to the negative 3, when you divide, you're actually subtracting your exponents. So x squared divided by x to the negative third is actually x to the 5th. So it works, but there's a lot of, you'd be really open to messing it up. But yeah, it does work. Okay, good. That's it.